Well, welcome to Daemon Labs. Say some of you have been here before, some of you it's a new experience for you. Um, we've done a few of these before. Um, this is, I think, the third one we're now doing. And there's a couple on the screen there if you're interested in the future ones. Don't worry, we'll share the links at the end again as well. Um, just a bit about Daemon, because it'd be naive for me to at least not tell you who we are. Daemon is a consultancy company. We've been around since about 2007. We were formed by our two founders, Stephen and Callum, who were consultants in Sainsbury's at the time. So might not be a surprise that Sainsbury's is actually one of our biggest clients, and have been with us since that time. Um, but we are formed of a number of different kind of what we used to call practices. We've recently switched to kind of like centers of excellence. Um, and this slide is a little bit outdated now in the sense that AI has become its own pillar. But it's still the same kind of behind the scenes, still pretty much the same kind of deal. But you see cloud and platform, that's where I am. So sorry, I haven't actually introduced myself. I am Gary. I'm a principal consultant here at Daemon, and I focus on cloud and platforms. We've got our data and ML, and as I say, AI, they're kind of ever so slightly separated now. Digital engineering, so software engineering, all of that kind of stuff. And at the bottom, we've got delivery excellence, basically making sure that the rest of us do what we're meant to do and deliver it in a good way. So that's kind of what we are and what we do. Um, coming into the workshop today, hopefully you've gone through the prerequisites and you've got these two things up and running, because these are basically the most important ones. So Docker, we've got installed because even if not at a company level, at a personal level, I very much believe that everything should run in a container. And I will explain to you during this workshop why that is. Um, but we can, yeah, basically just like this workshop requires Docker. And we need a code editor. We we recommend VS Code mainly because it's free. There are other editors out there. So, for example, you can get like through is it IntelliJ that do, or IntelliJ is that the actual JetBrains? That's it. JetBrains do IntelliJ, but you'll also things like PHP Storm and other more language specific editors. But that one you pay for. So, say VS Code is a free one, and it does exactly what we need to do for the sake of these workshops. Um, so why is it important? I have this slide on each of them. The reasons do change from workshop to workshop, but there's usually an underlying kind of reasoning for it. So for this particular workshop, because we're looking at Terraform, so firstly, who here has used Terraform before? Just quick show of hands. So you're on the cusp. Have you ever used Terraform? No. Okay. So do you understand what Terraform is and what it does, or is this completely new? Cool. So Terraform, it basically is what we call infrastructure as code. So if you've ever used any kind of um, cloud or otherwise based provider, let's say, for example, AWS or Azure or Google, what you might commonly do if you've never used something like this before is go into their console, look at that UI, and start clicking around and creating resources. Now, if you go from, say, like a dev environment to a production environment, so you've got a safe space and a space that you're expecting your customers to use, you've got to remember what you did from one to then replicate it to another. What infrastructure as code allows us to do is make that repeatable so that you're not guessing what you did last time. Because when you click around, you might press something, and then later on, when you try and do it on the next one, it's gone because you did it about half a year ago, or even a week ago, if your memory's a bit like mine. So that's kind of what we mean by infrastructure as code. It's basically a way of um, borderline programming, but it's not as advanced isn't the right word. I would probably call it infrastructure as config, because the structure of it is more configuration than it is programming. Now, people might argue that one, but that's my personal approach to it. Because I say, if you say infrastructure as code, some people go, "Oh my god, code! I'm not a programmer kind of thing. As a for me, it's more around configuration than it is code. Um, what we're doing today is we're not actually using AWS. We're doing all of this on our machine, no credit cards, no accounts, no nothing. We're creating a safe space, especially if you've never done this before, a safe space for you to learn this without breaking the internet. Um, so that's what we're doing there. Um, these are the two that always come up in these kind of workshops, and it is part of the reason why we're looking at containerization. Is like, what version of Terraform have you got installed? You've already asked that one since we got here today. You asked, does it matter if I've got an out-of-date version? Because we're using containerization, it doesn't matter because we're not using what's installed on your laptop. We're using what's inside the container. Yeah, and I'll dig into that a little bit further shortly. And that age-old kind of sentence, it works on my machine. By using containerization, we're creating consistency across the board. So here today, I've got a Mac, I can see a Mac there, and I can see a few Windows machines as well. What we want to do is make sure that if you work on a piece of work and then you share it with a friend or a colleague, it works in exactly the same way, or as close to as possible. Because obviously there are sometimes nuances, but as close as possible without worrying about if it works on a Mac or a Linux or a Windows or anything like that. Does those reasonings kind of make sense? Yeah. Cool. So what we're going to do then is this is the workshop we're looking at today. We're going to kind of do the initial setup basically to create our fake cloud locally, and we're going to make sure that's running. We're going to set up Terraform, and we're going to provision a resource or two so we can actually see something happen. We'll take a break at that point because you'll probably all be bored of hearing my voice, and I'll probably need some water or something. And we'll come back and then we'll see about how we can do some slightly more advanced techniques to make that more scalable. We'll also look about how to understand what's happened under the hood. Not too deep, but just obviously exposing the magic, I guess, basically as to how it's working. And then obviously when we get to the end, we'll do a bit of cleanup and we'll leave the room all happy and not too confused by anything I've told you. So we're going to get into it. This is where some of our previous learnings have hopefully helped us. So if you go to your Wi-Fi connections on your laptop, you've probably already logged into the guest Wi-Fi. If you haven't, that's absolutely fine. There will be a Wi-Fi in there called Daemon Labs. What I'd like you to do is to connect to that one, please. And the password is exactly the same as the name, Daemon Labs with a capital D and a capital L. And then once you've connected, if you go into a browser, Chrome, for example, and type in the IP addresses on the screen. So it's 192.168.1.5. You should see a screen a little similar to that. Has everyone been able to do that? Basically, what we're doing here is we're downloading some of the resources for this workshop, not via the internet. Because if I got you to download them via the internet, our internet would grind to a halt. So we're preempting this a little bit. Is everyone okay? Like on what? Sorry, the IP address is that I can tell you what it is. It's 192.168. Oh, yeah. Oh, so have you? Yeah, that's fine. There we go. Brilliant. Yeah. I've got the magic touch. Just hold fire a second. Have you managed to get that screen up now? Yeah. So brilliant. We solved the Windows problem. There we go. That's the problem we had last time, wasn't it? So we've solved the Windows problem. Or we've solved one of the Windows problems. Once you've got that open, there's two buttons on there to download two files. Please click both of those buttons. Are they downloading okay? Yeah. Down Yes, it would have said that. So if you're using Chrome, you press a button that says keep on it and it will then download them. No, it's but basically what you're downloading from is that laptop there, on the little coffee table. Just make sure everyone's up. They are, but it should still be quick enough.
Can you bring up the address again?
Oh, sorry. That's it. Yeah. So if we go to the beginning. Oh, sorry.
Yeah, we did.
We've done this already, haven't we?
Yeah. Yeah. Same.
Oh, it was missing a colon, I think.
No, we didn't use it.
Thinking about it. Let me just make sure the laptop's still on. See, this is going to make for a great video recording of us trying to debug this. But hey.
At least we'll have it on video for the next time.
Yeah, right. Sorry, I've just opened the laptop. It might be the laptop had gone to sleep. Brilliant. Right. Okay. I thought, there we go. There's a lesson for next time. Then I need to change the battery settings because it's plugged in. I need to change the power saving settings to make sure that it doesn't go to sleep after a certain amount of time. Right. So is everyone able to download this now? Yep. Right. Okay. Maybe I will do some little editing on the video just to take out that bit, but I'll remember it. Right, has everyone been able to download the files? Still just downloading. Okay. While those are downloading, there's another link on there which says to open the workshop documentation. So what we want to do now then, hopefully you've got a terminal available to you. So on Macs, it's just called terminal. On Windows machines, it'll be PowerShell probably. So if you can open up that. And then what we're going to do is we can literally copy and paste a lot of the things in this tutorial or this workshop, and we can then paste them into that terminal. Now, to create this folder, I'll give you two options. Either do it via the terminal, or if you'd rather do it through the File Explorer or Windows Explorer, you're more than welcome to do it that way. But the point is, we just want to create a folder that's dedicated for the work we're about to do. So if you want to copy this, and for me, I'm going to use the terminal. So I'm going to open this up. I'm going to paste it in, press enter. It's as simple as that. And then what I'm going to do, and what I would recommend, is opening up VS Code. I'm going to open folder, so file, open folder. And it'll open up a little dialog. And basically you just find the folder you just created and open it. And VS Code will ask if you want to trust the authors. You are the author, so I'm pretty sure you can trust yourself. If you don't, then, well, you're in trouble. But then basically you should see a window like this. Pretty straightforward. It's just an empty window. I will zoom in a little bit because I realise it's a big screen. But basically on the left-hand side, you've got Docker, Terraform, AWS, nothing else in it, and then just a welcome screen on the right-hand side. Has everyone got that? Cool. So coming back to this, what we can now do is all have the same terminal window. It makes things much easier. So if you go to terminal at the top of VS Code, you can see it says new terminal. So we do that. And then on the bottom, it'll bring up this little window for us. And basically everything else we can do here now. So it becomes much less complicated. Is everyone in the same place? So we downloaded those files, and one of them is the Docker images. And what we want to do is basically load them into Docker. So if you've used Docker before, you probably would have done like Docker pull and then an image name. That tar file that you've just downloaded already contains the Docker images. So if you want to kind of copy that command there that says docker load downloads, and what we can do is paste that into our terminal. Now, this does assume that's where they're downloaded to. If you've downloaded to a slightly different location, you'll need to update it accordingly. But I'm going to move that over a bit. Once I press enter, cool. So as I say, sorry, if you scroll down the prerequisites a bit, there's a bit here that says about an in-person workshop. Cheers, man. There's a little bit here. We can expand this. We get some more information. As I said, we've already downloaded the file, so that's all good. We're going to run this little command here. So you can copy that. And if you've now got VS Code open, I'm going to try and run this again now. There we go. Thinking about it now. Basically, say what this is doing is there are 3 images in that tar file, one of which is Terraform, one of which is an AWS CLI, and one is something called local stack. I will explain what all of those are soon enough, but hopefully you've all just seen a similar output. Cool. All right, so we're just waiting for that to kind of all come through. So for those of you that it has worked, you can now copy the next command, which is docker image. It's still churning through it, is it? Okay. All right. Well, if you see my screen, for example, mine is finished. I've now got I've got 4 images loaded because I've got one that wasn't inside that file, but there's the 3 images there that came out of that file. So I promise we will do some Terraform. So the last thing, right? Let's skip this bit. Let's move on. Let's actually do something, okay? So the other thing I was going to do was try and pre-install the Terraform providers, and I think, to be honest, like we're already at 7 o'clock and we haven't even typed a tiny bit of Terraform yet. So let's move on. Right. So has everyone got VS Code open with the Docker Terraform AWS in the top left-hand corner? Yeah. All of us barring one are on this screen. Yeah. Right. So what I'd like you to do: right-click, create a new file, and it's .env. Might look a bit odd to type it like that, but trust me, that's what we're going to create. And all I want you to do is copy those 4 lines there, paste them, and save them. That's it. Close that file. We're done with it. The next thing we're going to do is actually do something with Docker. Now, we're going to create a Docker Compose YAML file. Who here has used Docker Compose before? Who here hasn't? Okay. Those of you who haven't used Docker Compose before, have you used Docker before? But you have, though. Yeah, so like you understand, like Docker run something. What basically Docker Compose is, it is a way of basically orchestrating one or more container. So rather than say Docker run this, Docker run that, we can say Docker Compose run multiple things at the same time. So in this particular case, if I bring this down a bit, assuming everyone has been able to copy and paste this okay, we have defined services in which we've said we want a local stack container and an AWS CLI container. So local stack is basically AWS. I say shrunk down, it's a 1 gigabyte image, but the point is it can run pretty much AWS as close to the cloud as you can locally. The point is there's no credit cards, there's no accounts, nothing like that. You can run AWS without kind of worrying you're going to break anything. The reason we've got AWS CLI as a container here is because some of you may already have the AWS CLI installed. You may also have it with existing AWS credentials. What this does, it ring fences it. We're basically saying the environment variables we're setting here does not affect your AWS CLI that you've got installed on your laptop. Okay, so we're just, as I say, we're ring fencing it. We're just making it safe. We're containerizing it. Clues in the name. Has everyone been able to create this file? Yeah. You guys good? Yeah. Good pizza. Yeah. What we're now going to do is basically confirm that AWS runs. Now, you guys run it, that's fine. So you see down here, I've got docker compose run --rm AWS -- version. Now, if you were running this locally, it would just be AWS -- version. Now, the first time we're running this, it is going to take a little while, because if you notice in our Docker Compose file, we've got a dependency, and our AWS CLI has a dependency on local stack. And because local stack is still that big, what we're doing is we're waiting for local stack to start and be healthy. Local stack has a health check in it, meaning when it is healthy, it will say to Docker Compose or Docker, I'm good to go. And at that point, when we get that signal, AWS will start kicking in. So you can see here, mine is now finished. Hopefully yours have all done something similar. You've got AWS CLI 2, Python 3, Linux, something, something, something. It doesn't matter about the actual details, but the point is we should all have kind of got on that screen now, and they should all look very similar. If you were to run AWS -- version locally, especially for the Windows guys, you would have got something different. And even for the Mac users as well, you would have got something different as well. This kind of what brings me back to the idea of containerization, is creating that consistency. So that what you run, what you run, so on and so on. Yeah. See, I can actually teach something when we're not dealing with prerequisites all the time. And that's my bad. That's obviously something I need to take away. The last thing we're going to do here is basically make sure that the AWS CLI is doing something. So again, you could run this on your normal version and you would get something that is relevant to you and your AWS account. But running it here, firstly, you'll notice is much quicker now. The reason being is local stack is already running in the background. The first time it spun it up and it got it running. The second time it was already up, it was already healthy. So it meant that AWS could just get on with it. So you should get exactly the same output. It says something, something example, all the zeros, and then basically saying we are the root user for this fake account. Yeah. So that means it's running, it's working. So believe it or not, we've actually got through the first step of this workshop. We're going to do some Terraform. So first thing we're going to do, we're going to create a Terraform folder. Now, something that's quite common with Terraform, and especially when you're doing Terraform for applications. So let's say you want to deploy I don't know, a Node TypeScript application or a Python application, you'll quite often find that you'll have Terraform living inside the same application code base. So I would suggest, or I'd recommend, that your application code goes into something like /app or /source, and then you have a /Terraform to keep your Terraform code separate. It's just sensible separation so that files aren't getting mixed up. Now, you can run that in your terminal here, and you'll notice that I've now got a new little folder that says Terraform. This is where we're going to create all of our files, okay? Excuse me. And the last thing we're going to do in this case is we're actually going to add Terraform to our Docker containers. So I've still got Docker Compose open. All I need to do is copy and paste it with a slight caveat that it needs to be indented by 1. So if you see my screen, you can see that I've got the whole thing highlighted. When you pasted it in, it was probably here. If you highlight the whole thing and press tab once, it'll do that. Okay? Has everyone been able to do this? I promise we're going to do some Terraform in a minute. We all good? Yeah? So, once you save that, and we can ignore this bit because this is the bit I decided to ignore because I think it would have taken too long. We're going to make sure that Terraform works. So much in the same way we got the AWS CLI to work, we're going to do the same thing. Oh, excuse me. So in the terminal, Docker Compose run --rm Terraform version. Does anyone actually want to tell me what the --rm's for? Ah, you're trying to remember from last time, aren't you? Does anyone know what the --rm does?
You know what it does, but I don't know what this does.
No. So --rm. So basically, it removes the container once it's finished. Yeah. So with Docker, and especially running on a laptop, if you don't have something like this, you will soon find out that your laptop borderline crashes, because basically you'll have lots of containers that are hanging around from previous work you've done and stuff like that, and Docker images that go with it as well. So for containers, at least, there are resources wrapped up with them, even if they're not running anymore. Like not much, but it builds up. So in a case where we're running something and it exits, the --rm says once it exits, get rid of it. So we're going to run this, and you should see something like this. So I can see you've got Terraform in there now. So if you just scroll down the documentation a bit, you'll get the Terraform command. Did everyone get 1.14.4? Yeah. Now, this is what I'm saying about using containers. Every single one of us is using the same version. Before we started this workshop, I got the question of, what does it matter what version of Terraform I've got installed? Terraform versions can change from project to project, and quite often you'll find that someone will have used whatever version they've got installed, and then when it kind of comes to you, you've got a different version. All of a sudden things are working differently. By doing Terraform inside a container, you're creating that consistency. Now, there are some caveats to that, but I don't have time for that right now because we lost a fair bit of time at the beginning. But the point is, we are now at a stage where we can run a Terraform command, and it's going to do nothing. So let's run Terraform init. I've initialized a Terraform project in an empty directory. So whenever you're running Terraform for the first time, you need to initialize it. Much in the same. Who here does application programming? Anyone at all? Java, Node, Python, PHP, any of those? Yeah. When you did you have dependency installations? So like library stuff like that. That's exactly what we're doing here. So PHP would be composer install. Node would be npm or something else install. Python is whatever crap they use. Java, and so on and so on. We're doing exactly the same thing here. Yeah. So when we're installing providers, which is what we were going to try and do at the beginning, or modules, this is what we do. We run the init and it downloads them for us, okay? Because we're in an empty directory, there's nothing to do. And that's fine. That's exactly where we want to be right now. So what we're going to do is we're going to define those providers. So those of you who have used Terraform before will quite often... That's all right. Yeah. So what I was going to highlight just is that much like other programming languages, Terraform actually has a style guide. If you've used Terraform before, you might find you've just got main.tf and everything is thrown in at it. If you open up this style guide here, it's defined by HashiCorp, who create Terraform, and I would always strongly recommend follow that, because it removes any opinion and any arguments you may have with fellow engineers and developers in the future. We're going to follow that style guide, okay? So what I would like you to do is we're going to create what is called the terraform.tf file. So in the root here, we can create a new file. And if you paste that in with the folder name, it creates it in the right folder for you. And then all we're going to do is copy this and paste it in. So what we've defined here, and if you ignore my AI trying to fill in stuff for me, is we've defined the required version for Terraform to be 1.14, or at least 1.14. And we've also said that we want to install the AWS provider being version 6 or higher, but no higher than 6. So I'll explain that properly in a second, because when we install it, it's going to take a little while because we're doing this over the internet now. So if we create a second file called providers, and we're going to define our AWS provider. Now, those of you who have used Terraform before may have seen this. Some of you haven't. That's fine. You can actually define some default tags with your AWS provider, meaning every single resource you create that supports tagging will automatically get that tag. Meaning when you create resources, you don't have to define the tags every single time, okay? What we're going to do then is we are going to rerun that init command. Now, because we're all doing this on the internet, this is probably going to take a little while. but you'll start seeing this kind of thing here where it's saying is initializing provider plugins, and it will start downloading things. So if I come, while you're doing that, I'm just going to quickly explain what's going on here. Now, again, if we go back to other programming languages, when you include dependencies and whatever else, you'll see things like version is this, version that, greater than this, greater than that. Terraform has this nice little feature where you can do a tilde greater than. And what it means is the last set of digits can be that or higher. So when I've defined 1.14 with that little tilde greater than, it means it can be 1.140, anything within 1.14, or it can be 1.15, 1.16, anything in there, all up until the point version 2 comes in, at which point it will not install that. Okay, does that make sense? It's quite a nice way of being able to limit it. If I just did tilde greater than 1, it would automatically start installing version 2, which is a major version, and you'll start getting problems. I could also limit it. I could also put 1.14.0, meaning it would never go greater than 1.14. Anything inside that, it will install the patch versions automatically, but it will never install a new minor version. I can see people nodding and kind of agreeing with that or understanding that. Does that make sense? I will always lock it. I tend to always lock it to a minor version because usually, if they're following semantic versioning, a new minor version won't include a break and change. That doesn't always happen, but that's what's meant to happen. Similarly for the AWS provider here as well, I've locked it to 6.0, basically meaning as long as it is version 6 of some kind, it will install it if a new version's available. Has everyone been able to run that init command? You guys are good? You good? And you're good over there. Brilliant. Okay. So that was actually one of the going to be one of the sticking points because we thought we were going to have to do it over the internet, and we did, and we're fine. So let's run a plan. Absolutely nothing, because we haven't defined any resources to create yet. So sorry, I maybe cut you off a little short there. You're absolutely right. A Terraform plan will tell you what Terraform plans to do. But because we haven't defined anything in our code yet, there is nothing to do. So we get this message here saying no changes. Yeah. So believe it or not, I promised you we would create something. Let's create something. Now, because we are using local stack, there is a slight quirk with how it wants to create S3 buckets, and it's only because we're using local stack. So I've still lied to you in the sense of we're not actually creating anything just yet. We've got one final piece of the puzzle. So if you open up the Docker Compose file, and where we've got this here, we're going to add a new environment variable like so. Has everyone been able to do that? Yeah. What we're then going to do, back in Terraform land, is we're going to create a variables file. So again, you can right click here, new file, and it will create it in the correct folder. And then we're going to add this variable. Okay? All good? The last thing we're going to do, you can copy and paste, replace the whole thing here, just easier. If you open up providers, highlight the whole thing, and save that. So what we've said is, in Docker, we're going to set this environment variable to true. In Terraform, we've made a variable available for that environment to set. It defaults to false, which means if you're using this in a real AWS account, it will default to false. Because we're running this locally, and because of this slight quirk with local stack, we've overridden that false and set it to true. And then lastly, we've updated our provider to use that variable. So I think by default it is false. We've put an override in. Okay. So lastly, yes.
I didn't quite get what was the purpose of that last bit that we just finished.
So as a local stack, what we're using to replicate AWS locally has got a bit of a quirk with it. I don't know the actual details of why it does it this way, but basically when you create an S3 bucket, there's two ways to create an S3 bucket. And this one defaults to the not default way of doing it. So all we're doing is we're just glossing over that quirk by putting this in place. As I say, because it's a variable, if you were to run this same Terraform code on an AWS account, you wouldn't need to override that variable. Just leave it as it is. Which is where, like in the Docker compose file, basically, if we decide we want to run this against an actual AWS account, oh, sorry, fat thumbs. If we did that, it means that the variable would default back to false, and then it wouldn't worry about this quirk. But just because we're using local stack, we need to do that override, okay? I know that doesn't necessarily answer your question, but yeah, it's for the sake of this, that's what we're doing, okay? So we're getting so close to actually creating something. We're going to create this last file, which is main.tf. Who here has seen a main.tf file before? One person. Have you guys seen main? Right, okay, cool. Main.tf is basically in theory, it's the main file. The clue's in the name. It's not anything that's like, if you don't do a main.tf, it's not going to work. It is just kind of like an unwritten rule that you have a main.tf file. So what I'd like you to do is I'd like you to copy and paste that piece of code into this file and save it. Don't forget to save it. And then what we're going to do, believe it or not, is create one more file. And it will all make sense in a minute. Don't worry. This is coming to some form of conclusion. We're going to add something called an output there. And I'll explain what these are in a minute, okay? But once you've got that file and you've saved that file, we're finally going to apply something. Now, not to shoot anyone down, but would anyone like to tell me what apply does? It creates the actual resources. So if you hit apply, and I'm just going to expand this window a minute just so you can see what's going on. I could have run a plan first, and the plan would have done exactly the same output, but then just gone back to like the terminal cursor. What apply does is it outputs the plan and then asks you at the bottom, do you want to perform these actions? So what we're doing here is the plan, right? So what it's saying is we've got two resources to add, nothing to change and nothing to destroy. And if I scroll up slightly, what we're doing is we're creating an S3 bucket. Has anyone not used AWS and not used S3? Does everyone know what an S3 bucket is? Yeah? Right. It's a bucket, right? Somewhere to put files. We're creating an S3 bucket. And have you noticed here, the tags have got that tags in there as well. So because we've put those default tags in, they've been picked up here. The other thing we're doing is we've created what's called a public access block. Now, a best practice for AWS these days, and to be honest, should have always been the case, is to prevent public access to S3 buckets by default, because usually you don't want those files getting out to the internet accidentally, whatever else. So we've created these two resources to do that. So if you type in yes, and by the way, if you don't type in yes, if you type in yes and a space, it won't work. It'll basically say, oh, you've cancelled it. If you type in yes and press enter, you should get something like this. And what it's saying is it's creating a bucket. The creation was complete. Creating the access block, and the creation was complete. So apply complete, two resources added, no changed, no destroyed. And there is our output here as well, which is what we created in the outputs.tf file. So the output we created was basically to tell us what the ARN of that bucket is, which is basically AWS's like unique identifier. So believe it or not, you have just created an AWS resource. I promised we would do something with Terraform. We've just done something with Terraform because I think there's some of you in this room who've never used Terraform before. And what we've just done, and I know it took a while, but what we have just done is kind of get our local AWS environment working. We've confirmed that with that AWS is running, and we've actually been able to apply some Terraform. Now, say this is what we've seen. And the last thing we're going to do is we're going to verify that that bucket actually exists. So what you can do is copy this command, which is using the AWS container. And if you run that, what you can see here is it's queried local stack and it's found that bucket. So not only did that apply actually work, we've now actually verified that that bucket exists inside local stack. So if we were using an actual AWS account, you would have been able to log into the account, gone to S3 and seen that bucket listed in that UI. Does that make sense? Have you got like a warm fuzzy feeling that you've just created something? Yeah. When we got to the end of the first part of this, we'd successfully created an S3 bucket, and we'd set the access not the access policy, sorry, the public access blocking on. What we're going to do now is it might feel like we're kind of jumping the gun a bit here, but what we're going to do, we're going to introduce something called modules. Every single folder that has .tf files in it is called a module. Even the one that we've done is technically a module, but it's the root module. Okay. And what we're going to do now, though, is we're going to introduce reusable modules. Now you can create them much in the same way that we've created that root module. So we could create a subfolder and we could start creating resources. But given that we've got limited time, what we're going to actually introduce instead is open source predefined modules, which is a great way of being able to rapidly develop your Terraform to create, in this case, AWS resources. This GitHub organization is called Terraform AWS modules. And despite not being actually like official in the terms of, say, like HashiCorp or IBM, they are considered official from a community perspective. And if I scroll down, you'll see that they have, sorry, if I scroll back up, there are 61 repositories in here, ranging from being able to create a VPC, so basically creating an entire AWS network, to RDS, which is creating an AWS database, Lambdas, ECS, IAM, EKS, all sorts in there. What we're going to do is we're going to look at the S3 one, which is basically what we've just done, but we're going to do it in a modular way. We're going to copy this bit of code. We're going to go back to our main.tf file. And then at the end of this file, we're going to paste that piece of code. Now, what you'll notice is that that block is, what's that, 6 lines? Yeah. Basically, a provider and a module has downloadable parts to it. And basically, in a roundabout way, yes, what you said is correct. No, it's fine, it's fine. But as I say, a module, Terraform needs to know about it. And one thing I forgot to kind of highlight at the beginning is this .terraform folder. Now, don't accidentally create files in this folder, because this folder is ignored in the sense of your own code. And when I was saying about root modules, Terraform only works on a folder by folder basis. It will only listen to whatever files are in that folder. So as I'm saying, like that root module, any files there, it will listen to. If you've created a module and you've pinned it back to this, which as I say, I'm not going to show you today, but basically you can do where the source is here, you can do like // and then define your folder. But what this one is doing is saying, right, this is a third-party module with this particular version, and the version patterns are the same. We run in it, we download that. So at the moment in my .terraform folder, and yours will be the same, you can see that there's a providers folder and a registry, and there's all sorts of numbers and letters. So if we now run init again, so the code's in the repository, but you'll notice that .terraform folder now has a modules folder inside it as well. Let's go with Node because that's an easier one to answer. So Node will create a no modules folder in the root of the project when you do npm install. PHP will create a vendors folder. That's what this is. It's downloading those files into a folder that you do not commit to your repositories. Python, the reason Python's a bit weird is because it actually doesn't do it relative to the project folder. Python puts it in a root directory somewhere under your user directory. You could, so VS Code, for example, has a it's not just VS Code, but there's this concept called dev containers. I think the file you'd create in the root is called .devcontainer.json, and that essentially does create a container. Because of the way Python works, there have been a few different ways to kind of replicate that. I think the most recent version of it is called, I want to say it's UV. It symlinks what looks like a container, but behind the scenes, it's still creating, downloading the various files in your user folder. And then within your project, it symlinks the correct ones. So it feels like a container, but it's not quite a container. So you're not ring fenced in the same way as what a container is. Like a container, nothing can get in and get out unless you tell it to. With that particular one, you're still just on your file system. But say I used it the other week, and it definitely made it a lot easier to use Python. But it's still for me, everything has to be containerized. So just to kind of clarify, you don't need to do this, but just to show you, we've now got this S3 bucket which has got this in it. All of those files, and open up S3. So there's AWS S3 bucket. You can see all these files. They're the same files there. So it's basically downloaded the repository into this folder, okay? I'm going to close that folder because I don't want to accidentally kind of create anything. So now we've done that, we've done the init, we can see it's downloaded that. What we're going to do is we're going to add one more output into our outputs.tf file. So if you open outputs.tf, and after that one, add this new one. What we're going to do, we're going to come back to that file in a minute. And now we're going to do something actually quite dangerous. And I would never, ever, ever recommend doing this. The only reason we're doing this is because we are completely local. Never auto approve. Because you are literally bypassing that plan and say, yeah, whatever it says, just do it. And that plan and that gateway, that prompt where you type in yes, gives you the opportunity to bail out. And in this environment where we're using local stack and it doesn't affect anyone, absolutely fine. But in a real world scenario where you're using AWS and whatever else, I'm not taking responsibility for you using that, but it is there. So I'm going to auto approve this, and again, feel free to do the same in this particular case. But as you can see, it literally just hurtled through that, and it created two resources. And you can see our outputs. We've now got an additional output, but the output is borderline the same as the one before because we've now created two buckets. But the outputs look quite different. One is referring to AWS underscore S3 underscore bucket dot workshop bucket dot ARN, and the other one says module dot S3 bucket dot S3 bucket ARN, but they actually produce the same thing. The reason being is, and again, don't do this, I'm just showing you. If I go into modules and I go into that module and I find the outputs, what I will find is that particular output. So as I said, every single folder that Terraform has is a module. If you just treat it as kind of like a vertical, essentially, like as you go down, they've got the same files. They're just in a different folder and we've linked to them. what they do inside there is basically a way of abstracting away what you've done locally. So to clarify, that 6 lines of code has actually recreated exactly the same things we did with about 12 lines of code. So this is what modules allows us to do. It allows us to basically do a lot more with a lot less. Yeah. So if we went back to the output from the one we did before the break, you would have seen that it would have created an S3 bucket and it would have created the public access block. But again, even though this is in another module by someone else, because we've got that default tags defined at the provider level, it's cascaded down the whole way along. So what we're going to do now, yeah, like inheritance is probably a way of describing it as well. Oh, I didn't put it in here, but basically what I'm going to do, I'm going to rerun that AWS command. Sorry, I forgot to put this in the documentation, but now you can see we've got 2 buckets. Yeah. So it didn't seem like that, probably didn't seem like much in respect to kind of what we actually did. But let's say, for example, we want to go back to that code. And don't worry, you don't need to play along at this point. I'm just showing you some of the things we can do. So that block here is what enabled the public access block. But by default, that's done in that module because this is now best practice. So it's abstracted that away for you so you don't have to worry about it. Let's say, for example, you wanted to turn on versioning for your S3 bucket, meaning every time you uploaded a new file, it would basically keep the version behind so that you could revert back to it. If we wanted to do that here, see how well I can remember this stuff. There we go, bucket versioning, and we would say bucket, so on and so on. Like we'd have to put all of that in, kind of thing. Versioning is probably not the best example because but we can do the same thing with the module there, with just that small snippet. So if I was now to save that and run the plan, there we go. That would enable versioning for that bucket. There's a lot of things you can do with S3 buckets, like encryption, versioning, lifecycle policies. Like you can do a lot with it, but without the module, you're manually going off to Terraform, finding the resources, coming back, and then put them in your code, and then applying them or planning them first. With the module, say because it's abstracted away, it's just more configuration within that one bit of block, and you're basically picking and choosing what you want, and trusting that they are looking after it. So that's what I was saying about those modules. They're not official in the sense of like HashiCorp or IBM endorsed, but they're community endorsed by the fact that they have been around so long, kind of thing, and been worked on by so many people that the amount of trust is there. So in this next part, there's actually no work for you guys to do. I'm lifting the bonnet on Terraform here and showing you what it's doing behind the scenes. So Terraform works on what's called a TF state file. And what we are doing in this particular scenario is we are managing our state file locally. Similar to the auto approve, in the real world, I would not recommend doing that because it's only on your machine. For you to share that with someone else, you would need to commit it to a repository of some description. They would download it and you'd both have the same state file. The problem there, or one of the problems there, is that if 2 of you are working on the same code base and you've both got that state file locally, you've got a race condition. So for example, if you ran an apply and changed something, and then you ran an apply, you won't have the state file updates that you've got. That consistency is not there. So if you're working on like your own project, no one else is ever going to work on it. Doing what we're doing today by just using the state file locally is absolutely fine. And when I say state file, what I mean is this file here. Can everyone read that okay? Do you want me to zoom in a tiny bit? We're starting to get a bit bit blocky. So a state file is kind of what it says on the tin, really. It's a file that stores the current state of what you have applied, not what you've planned, what you've applied. If you were to run a plan, this wouldn't update, because a plan is basically what it's planning to do, not what is actually done. When you run an apply and actually go through with the apply, it updates this file. So just kind of working through it a little bit here, you can see the outputs are there. So you can see the two outputs, and it can say, well, that's that one, it's a string, and that's the value of it. That's that one, it's a string, and that's the value of that one. If we scroll down slightly, and if I start kind of closing this down, we're now going to start looking at the actual resources. Now, this file is difficult to kind of navigate, generally speaking, in the sense of like, there's a lot going on. Now, there is one other reason why it's really not recommended to keep a state file local or commit it to Git. It's not encrypted in any way, shape, or form. Everything is in plain text. If you were to create a database in AWS, and an RDS, for example, last time I checked, you have to define a root password for that database. By default, and I'll explain why I'm saying by default, Terraform will store that as plain text in the state file. Now, two ways in which we can resolve this one, maybe more, but two I can think of. One is to use a new feature that has recently come out in Terraform called an ephemeral resource or variable. What that means is it won't store it in the state file, but you need to give it that value every single time you run Terraform, because otherwise it will try and update it every single time. So a good way of doing that, and I'm hoping I'm not confusing things too much here, would be to introduce another provider. So, for example, has everyone here used some sort of password manager? 1Password, Keeper, something like that, yeah? Vault, for example. Vault would probably be a good use case here, right? So basically, what these services are is basically usually a SaaS piece of software. You log in and you say, here's my password, and you trust that they're storing it securely for you. If we take Vault as an example, because obviously being IBM, HashiCorp, whatever you want to call it these days, and Terraform, there is a Vault provider, meaning where we've defined AWS here, we could also define Vault. And what we could say as part of our Terraform plan and apply is, right, I want you to go and get this value from Vault, use it as an ephemeral variable in Terraform, and use it as the password for the database. Meaning that it's never stored in the state file, but there is a consistent way of getting it every time you run that plan or apply. Does that make sense? Yeah. So that's one way in which you can deal with sensitive data. And as I say, it's fairly new. So not everything is supported yet. But obviously, as time goes on, more providers will find ways of supporting that. The other way of kind of resolving this is obviously clearly don't commit this to your Git repository, because you never want sensitive data in there. But you can use what is called a backend. And a common one, especially if you're using AWS, is an S3 bucket. So in that case, you've got a little bit of a chicken and egg situation here, because you need the bucket to store the state file in, but we want to use infrastructure as code to create the bucket. So again, I'm not going to deep dive into that one. There's ways in which you can do that, but let's just accept the fact, for the sake of this conversation, you go into AWS, you create an S3 bucket, and then in here you can create what's called a backend to say, this is where to store the state file. And it will store it there. And obviously you can turn encryption on, whatever else you need for that S3 bucket. And what happens at that point is, locally, you have a temporary version of the state file, but it's not the golden version of it. The golden version of it is in S3, which means if you make an update, and especially if you turn on something called lock file, if you do apply, a lock file kicks in. If you try and do an apply at the same time, won't let you do it. If you finished, state file's updated, you then run the apply or a plan, it's got the updates. So that way you've got that consistency. Yeah. Um, so those are a few different ways in which you can kind of deal with that kind of thing within state files. But when you're in S3, unless you're using those ephemeral variables, it's still going to store plain text values in S3. So with that, and basically what I'm saying is make sure you put the right security steps in place to make sure that you're not like leaking sensitive data. Okay.
Environment variables to save us stuff.
Yes, yeah, you can use environment variables. So like we actually did that here, right? So we defined this environment variable. What I can do is learn how to type. Is mark something as sensitive. And the moment when that will not stop it from storing it in the state file as plain text, but on the outputs, you can see, for example, we've got bucket and that's the name there. Let's say, for example, we said, just for argument's sake, we said the bucket name was sensitive. That would be starred out. So on the output, it wouldn't display that value, which especially when you're using something like GitHub Actions and you're using pipelines to run your Terraform, it means that not everyone suddenly sees your sensitive data. So you could do it within environment variables. Yeah, sure, that's one way of doing it. And especially with GitHub or other kind of services, you can define those environment variables and secrets, and then they get injected like that. So there are definitely there are a number of ways in which you can do it, and that's one of them. There is an assumption in that case that you both have access to AWS. So that typically means running AWS outside of a container. So you have a user account on AWS, you have a user account on AWS, you log into AWS CLI locally. When you do a Terraform init, it will use those credentials to be able to access that file. That's probably the simplest way I can describe it. Again, there's layers of complexity you can add to that in terms of adding extra security and whatever else, but that's kind of the root of it, is that's how you would do it. These files here, you would commit them to a repository. And obviously with that, you can then all download, assuming you got access to that repository, you can download it. If you've then got the access to retrieve the state file, when you run an init, it works in the same way as the provider and the modules. It downloads that state file. If you're, and sticking with AWS here, if you're then making changes to AWS resources, if your user has got permissions to make those changes, then you can apply the Terraform. Now, easy one here would be to say you've got admin access. And again, real world, I do not recommend that. But it's the simplest way to be able to go, yeah, I can get the state file, I can make whatever changes I want. And again, going to like a pipeline, and obviously that's actually the workshop we're doing in a month's time, is how to deploy a Lambda via GitHub Actions. Terraform will make an appearance in there. And it's, you don't really want your pipelines having admin access, because again, blast radius wise, if someone gets in, a lot of damage can be done. But if you want to kind of control it, just to say, oh, I only want my pipeline to do lambdas and IAM, but not be able to give full admin access, then those are the kind of things you can kind of sort out. Did that answer your question? Yeah, wasn't sure if it did or not. Any other questions for the minute, or does everyone kind of understand what's going on here, at least vaguely? Anyway, vaguely is good enough. I'll take vaguely. So that state file, as I said, is the current state of what Terraform is expecting to see, in this case, AWS. Okay, so we've got an S3 bucket here. We've got that there. Another S3 bucket, and then the other bit. Anyway, so as you kind of highlighted, it said no changes. So if I was to run plan at this point, oh, I turned versioning on, didn't I? Sorry. Let me get rid of that quickly. So if I run plan now, I will get no changes. The reason being is the resources that have been created and the state file and my code all match. So as far as Terraform is concerned, there are no changes to be made, okay? So again, looking from a CI/CD pipeline, that's great because it just means we can just run it every single time you merge into main or whatever else. If there's a change to make, it'll make it. If not, you'll see that. But the other thing with the state file is it can do drift detection. So what I'm going to do here is I'm going to forcefully delete one of my buckets. And I can prove that's happened by rerunning the s3 ls command. And now you can see I've only got one bucket instead of two. Excuse me. If I now rerun plan, it's picked it up. It even though it's in the state file, it does a check to make sure it actually does exist. And it's detected that there has been some drift. So now it's trying to correct that drift. So it's saying, I want to create that bucket and I want to create the access block for it as well. So, okay. Let's do the apply. We get that through. And then lastly, I rerun the S3 command and I've got two buckets again. Because we deleted the bucket, this access block here got deleted as well because it's part of the bucket. It's basically a setting on the bucket to say don't allow public access. But because we deleted the bucket, it in turn deleted that as well. So when the drift detection happened, it detected the bucket wasn't there and in turn that the public block wasn't there. Okay. So believe it or not, we've actually come to the end of the workshop. So nearly come to the end of the workshop. We've got to look after ourselves. We've got to clean up after ourselves. So first thing we're going to do, and this is where you guys come back in now, okay? What we're going to do is we're going to destroy the resources we created. Now, again, destroy is not a command I recommend using on a day-to-day basis because it does exactly what it says on the tin. It destroys everything. If you do this on a production workload or even a dev workload, you're going to get some very angry people unless you're absolutely sure this is what you want to do. But the point is, based on that state file, it's running through it and it's gone, well, okay, I've got 4 things to destroy. Nothing to add, nothing to change, but 4 to destroy. Yeah? So if you type in yes, it's going to destroy those 4, and I can confirm that by running the AWS ls command, and nothing's come back through. So hopefully you can all run that, and once you've typed in yes, you'll see that the 4 resources are being destroyed. Yeah? These are the major providers supported by Terraform. And what's quite useful is being able to actually list the official ones. As in, these are the ones that are maintained. I keep saying HashiCorp because it's ingrained in my mind, but HashiCorp is the company that created Terraform. HashiCorp kind of does, kind of doesn't exist anymore. It's now part of IBM. IBM bought them out a little while ago, which I got reminded of this evening because it slipped my mind. Because as I say, HashiCorp is just so ingrained in my mind where I've been using it for so many years. But you can see, for example, I guess the 3 key ones are up there: AWS, Azure, and GCP. Kubernetes is obviously quite a big thing, or Kubernetes, however you want to pronounce that. Some people say Kubernetes. I've always said Kubernetes. I don't know. But if you scroll down as well, all of these providers are officially maintained by HashiCorp. I'm going to say HashiCorp because that's the name that's in the source. So just like for an example here, what have we got? What might we know? So Active Directory, for example, part of Microsoft. Oh look, IBM. There is one for IBM. So is there anything else there that kind of stands out? Random is a weirdly useful one because it does exactly what it says on the tin. It creates random strings like UUID, that kind of thing. But as I mentioned earlier, Vault. So Vault is that secrets manager. So there is an official provider for that. There are obviously other providers as well. So we're talking about kind of like partner ones. So here you'll find things like Oracle. Off the top of my head, I can think of Datadog. I think New Relic is in there somewhere as well. Just scrolling through here to see if any pop out. There's 8 pages. I'm not going through 8 pages. But I say those two, for example, I know are partner ones. They're not maintained by HashiCorp, but they are considered partner official. So I say Terraform does a lot, and we've just focused on AWS. In AWS, you could use CloudFormation. Don't use it. Terraform is great because it's technically agnostic, and it allows you to bridge multiple providers in the same place, meaning you can kind of have communication between multiple providers. As I said, like Vault, for example, and AWS. There's a great way of being able to say, well, go get this information from Vault, now use it in AWS. I could create AWS and Azure stuff in the same code base. I don't know if I'd want to, but I could. Is that kind of thing? So you're asking about like providers, like, yeah, the major ones are in there, and there's a lot you can do with it. Right, let's go back to tidying up. So remember I said at the beginning about the --rm thing, making sure we're removing the containers. What I want to do, because these are, well, apart from the ones that have got the spare laptops, these are your laptops. I want to make sure you leave here without garbage kicking around your laptop. So we've run a destroy. What we're going to do, you don't have to do this bit, I'm just showing you what's happening. I've just run docker compose PSA. What PSA means, or PS is basically show me any running services or containers, whatever else. And -a basically says, show me all of them. So if I did it without -a, it would only show me things that are running. With -a, it shows me things that have stopped, but still technically there. So we can see local stack is running. Local stack has been running this entire time. So it's been up for about an hour at this point. But we want to get rid of it. The other thing is the images. So some of you use Docker in your day-to-day work, so you might have more than me here. But local stack is the only one actually listed right now because it's the only one that's got a service. Oh, I've hit caps lock. If I was to run Docker images, there's actually those ones there. So what we need to do is we need to clean this up. So what we're going to do is we're going to say to Docker, or Docker Compose specifically, I want you to down all the services, basically shut down. It shut all the services down, and then obviously we've got 3 services, but there's only 1 currently running. We're going to say shut them all down, and what --rmi means is remove image, and we're saying remove all images. So if you run that, it will close down local stack, and then you'll see it's then also removed 3 images and 1 network. I didn't realize it was that funny. No, I say I know you've already got some work on your laptop, so you might well find it doesn't want to delete everything. Okay, cool. So now if I go back and I look at Docker images, I've still got 1 there because it wasn't being managed by this project. And then I've got no running containers. So now we have finished. You've successfully managed to get through that workshop with some curveballs along the way, but we've basically made AWS work locally. We've kind of generate, like some of you have never used infrastructure as code. In the last hour or 2, you've actually created some infrastructure as code. You've planned it, you've applied it, you've destroyed it. You've seen how you can kind of iterate on it so that you don't have to keep spinning everything up, pulling it down. You can apply it bit by bit and whatever else. We've done environment orchestration. So Docker Compose, you've been able to create a stack of services locally without installing anything else on your laptop. Like you will leave here today in exactly the same way you got here, because we haven't had to install Terraform, AWS, or anything else locally. It's gone, and your laptop is safe. And as I say, when we introduced the modules, we looked at, say, like the modular architecture.